Hi, my name is Nur Fatma Mansoori. This is lesson 6 of NLP series. So don't miss it. We're gonna study about derivation with naive Bayes and numerical stability and many more with regex. So don't miss this lesson because regex is really important. And let's get started. So these are the slides of today's video. So in this lesson 6 of our NLP series, we are gonna study about derivation of naive Bayes and numerical stability. So these are the highlights for today's video. This is the objective of today's video. These are the outlines. First we will revisit the randomized SVD and Bayes theorem, derivation of naive Bayes, numerical stability, IEEE Institute of Electrical and Electronics Engineers, then machine epsilon and speed of different types of memories, and then regex. Regex is actually regular expression. It is a very deep topic and detailed topic, so we're gonna study about in detail, so don't miss this lesson. Let's get started. So today you can see we have two notebooks for the regex and for the other topics. Regex is detailed as I told you, so we will talk about it later in the end. So first thing, so actually first I have described how can you handle the problem while installing fast AI library. So this is the most common issue while installing, so read it if you are facing the issues while installing the fast AI library. Then more revisiting our randomized SVD topic. So then I just put the key things I wanted you guys to show about and know about randomized SVD. So it's actually fast and it gives us the truncated SVD, whereas kind of what the traditional approach like it's like we are calculating the full SVD and throwing the unwanted stuff. And then if you are curious, I have got some details here. You can actually check them out, see more details. Bayes theorem. So remember Bayes theorem? Let me explain again if you guys forgot about that. So what actually Bayes theorem is? Bayes theorem is like a mathematical formula that describes how to update the probability, likelihood. You can say likelihood of a hypothesis based on new evidence. So yeah, so this example is from a book, Drunkard's Walk. You can see the poster of the book here. So the Drunkard's Walk, which I read some time ago, but really enjoy this kind of book because it has a lot of applications and how probability shows up in various answers. So the writer is a physicist, and in the book he shares the example that he tested positive for HIV in 1989, and his doctor told him that this meant there was a 99.9% chance that he had HIV. So this example you can see. So here are true positives. You can see true positives were 99.9%. The prevalence, you can see the prevalence was 0.01%. So I want you guys to calculate this problem using Bayes theorem to know exactly what like was his doctor really correct, because we just wanted to because it will really help you guys to like get better in Bayes theorem, and it is really relevant in like both medicine and dealing with false negatives and false positives. So assuming that you guys have answered this calculation and done it by your own, so yes, let me show you the answer. So the answer was actually 9%. See here, it was actually 9%. Not that difficult. If you solve it, you will get it actually what was happening there, and it is really simple. See, test positive, test negative, and then the total of, like, if there are 10,000 people, we are putting them in a bucket, and you can just solve it like this and calculate it. It will be really easy. So then we have derivation of naive Bayes. So derivation of naive Bayes, we are using it in our movie review. So the review is let me just scroll down. Okay, the review is I loved it. So I loved it, and we wanna know like what's the probability of being a positive review. So here we flipped it from we want to figure out the probability that's positive using our kind reviews. See, and then yes, so our kind reviews and okay, so the naive part of naive Bayes, maybe I mentioned somewhere, let me see. Okay, so let me just, yeah, here the naive part of naive Bayes is that we will assume that the probabilities of different words are all independent. Okay, so which is probably not the case here. So then we will do the calculation. Here we are calculating it. Then we will just do the calculation, and after that what we are doing is like then let me see. Okay, that's very simple. So we will do the calculation of what's the probability. It's negative, and then we will see which is more likely. Like, okay, so then we had just two classes of interest, but you could be doing a like classification problem with more than two classes. It is not fixed to two classes. Okay, so we add 1 to our numerator. You can see actually we added here somewhere. Yeah, here we added. So we are adding 1 to our numerator and denominator. Then uh, we are doing is just to avoid it dividing by 0, we also take logarithms to avoid multiplying by a bunch of tiny values. So if you're gonna if we are gonna go of this formulation, so we would kind of end up with all these probabilities, many of which are very small and multiplying by a lot of small values. So this can be really bad for our computers. So I'm gonna talk a little bit about it, like why is that. So first let's see this exercise, numerical stability. So take a moment to look at the function f below. We okay, it's scroll down. Okay, this function f. Okay, so before you try running it, write it on a paper and just run it on the paper, because it will really help you to understand what's going on in this function. Because sometimes our small functions can be really complicated and really hard to understand, even if we know it really well, like what functions are, how they work and all. So take a moment and do that before you try running it. So calculating, let me just tell what is going on here. So calculate x2 is equals to, or okay, this is not that function here. Okay, here we are running it. So how we are running it, calculating x2 is equals to our f of that answer, and keep going for 10 iterations. Here we are going to the iterations, those 10 iterations. See, there's a lot of infinite output, a lot of output. So what happened if I actually run this code and understanding the code. So let's just understand what was happening in this code. So this code actually, here you can see let me scroll up. Okay, so here you can see a function f takes a parameter x that returns 2x if x is less than, see, if x is less than or equals to 1 by 2, and returns us the 2x minus 1 thing if it is if x is greater than 1 by 2. See, if x is greater than 1 by 2, it is returning 2 into x, okay, minus 1. Then it iteratively applies this function to x is equals to 1 by 10. See here, let me just scroll down so you can understand better. So see, like it iterates through and applies this function to x equals to 1 by 10 for 80 iterations total. See here, 80 iterations total. So printing each updated value of x. So the result of this code will be a sequence of numbers, as I've shown you here. So result of numbers, which are like a sequence of numbers where x starts at 1 by 10 and doubles each iteration. See, we were doubling it here. See, 2 into x. So sorry. So doubling it, and then it will just double it each iteration until it exceeds with 1 by 2. 1 by 2 you can see here. Okay, at which point it subtracts 1 from the doubled value. Then it prints. The sequence will look like a binary representation of numbers. You can see here the output is like some binary numbers. So then this pattern repeats with a cycle of length 5 into 1 by 10 to 3 by 5, because once x reaches 3 by 5, it starts over with the value of 2 into x minus 1, which brings it back to 1 by 10, and then cycle continues like it's infinite. You may know about it. So what went wrong in this code actually? So the code lacks an explicit exit condition for the loop. As I told, it is an infinite loop. So yeah, it lacks an explicit exit condition for our loop, potentially causing an infinite loop if the function f with the parameter x does not reach a reaching pattern with 80 iterations. So let's understand a little bit about how computer stores numbers, so to kind of realize where these problems might arise. So we care about accuracy, like computers. Okay, like computers can't infinitely store accurate numbers, you know it. So a computer stores numbers in floating points, remember. So there are three parts. There is a sign. Let me just zoom it a bit so you can see it better. Okay, so 3 parts: sign, mantissa, and exponent. Okay, so the sign is the positive and negative, called the mantissa. So, and the exponent, the mantissa, the exponent, and the base, which is called the radix. So remember, this is called the radix, is assumed usually by base 2. So the sign is just a single bit. The sign is just a single bit. Okay, so this was simple. Then we have IEEE. So what is IEEE? So IEEE is the Institute of Electrical and Electronics Engineers in NLP, Natural Language Processing, refers to the standards and guidelines set by the Organization for the Development and Use of Technologies related to processing human language using our computers. So it got a maximum. See, you can. Numbers can be large as 1.79. So it got a maximum that is a double precision. So numbers can be largely as 1.79 times 10 with a power of 308. So that's pretty big. Or small as 2 times 10 to the negative power of 308. You can see how large it can go and how small it can go. Then the interval 1 to 2 is represented by a discrete subset. Okay, then we had a scale here. You can see we actually put it. Okay, so then we had a scale here. So this scale actually represents like floats and doubles are not equidistant. So they are not equidistant. So none of the smaller values are closer than they can be represented together. As your number gets bigger, like see, if here it is 4 and here it is 8, so the gap of our number gets bigger as well. See, from 8 to 15 it's more bigger. From 8 to 30 it will be more. From 15.5 to 30 it will be more bigger. So then we have machine OMG. Okay, what happened? Okay, machine epsilon. So machine epsilon, what is machine epsilon? So machine epsilon is the smallest positive number that like when added to 1, when added to 1, so the results in a value different from 1 in the representation of
floating point numbers in a computer. So we have some conditions here. Okay, so in floating point number, let me see. Okay, so in the floating point arithmetic, the difference between a real number x and its nearest, I am actually explaining these points in like detail so you can get it better. So in floating point arithmetic, the difference between a real number x and its nearest floating point approximation fl, see here fl with x, is always smaller in relative terms, represented as fl x multiplied by x is equals to x into 1 plus e, where e is a small value. So you can see it when you perform operations like addition, subtraction, multiplication or division. So on floating point multiplication, so on multiplication on a floating point numbers x and y, the result may have a smaller error denoted by e. You can see here I have mentioned it, I am just explaining. Okay, so denoted by e, so which is no larger than over e machine. Essentially every floating point operation is nearly exact with an error no greater than e machine. See, so yeah, let's just discuss about the different types of memory and their speeds. So let me explain these points. You can just get it as a reference after the class to just remember what you did in today's class. So let me explain what's happening here, what I wrote. So first they indicate the time it takes to perform various operations from super fast L1 cache access 0.5 nanoseconds to much slower tasks like reading data from a disk to 30 million nanoseconds or 30 million or 30 milliseconds. Okay, sorry, 30 milliseconds. So secondly, they help us understand the relative speed of different operations, like how much faster reading data from RAM 100 nanoseconds maybe is compared to fetching it from a network like 10 million nanoseconds or a disk from 30 million nanoseconds. So thirdly, so these values are crucial for optimizing software and over hardware, as they guide decisions about data storage, network communication and overall system performance. So you can actually check this interactive version here. Over here you can see interactive version, I have just linked to it. So which includes the timeline numbers, how the timeline numbers change. So key takeaway about what we have studied in this notebook. So it is like each excessive memory type is at least an order of magnitude worse than the one before it. So disk seeks are very low. So let's talk about regex now. So regex, let's actually talk about regex. So regex is a regular expression. It is a pattern machine language used to search, match and manipulate text based on specified rules. So the phone number problem, let me explain. You can actually just visit it after the class, because it's really simple, related to maths. And okay, so what we are gonna do in this phone number problem. So this problem involves identifying phone numbers within a data set that vary in format with or without hyphens and may contain errors, like you can see here actually 101. However, that's actually not a phone number, So and the task is to devise a method to calculate all valid phone numbers. So you can just see the regex and I just mentioned them here. Where are those? Yeah, you can just see the regex and without regex exercises, which are including the phone number problem. So that's really simple, just if else and some logic behind that. So you will actually really understand them. These are not the errors, we just tried that without regex and with regex. So yeah, introducing regex. So here are some resources I mentioned to study regex in more detail, because the more deep you go, you will get more things, you will see it like really crystal clear to you, the regex and its logics used in data structures and all in machine learning. So regular expression is a pattern machine learning, as I told you. So instead of writing, I mentioned it somewhere, yeah, okay. So instead of writing 0 1 2 3 4 5 6 7 8 9, you can write 0 to 9 or /t. So it is a domain language, DSL, powerful but limited language. So tell me, what other DSL language do you already know? Like SQL, the database one, Markdown, and TensorFlow. Then we have this refactored D character. So this refactored D character is meta character, which is one or more special characters that have a unique meaning and are not used as literals in such expression. For example, /d means any digit. So as I told you, we can use it from 0 1 to 3 to 9, so up to 9. So meta characters are special source of regex. Now actually talking about quantifiers. So what are quantifiers? So quantifiers in NLP specify the quantity or frequency of words or phrases in a text, such as some, all, or none, helping to express relationship and constraint between elements. So unexact quantifiers. So unexact quantifiers were actually in NLP, it introduce a level of uncertainty or imprecision when specifying quantity or frequency in text, like few, many, and several, allowing us for a more flexible and approximate description of elements. So then we have pros and cons of regex. So as we are introductory to it, so we should know about that. So the pros and cons are, what are the advantages of regex? The pros: so concise, it is so concise and powerful pattern machine DSL. So and it is also supported by many computer languages including SQL, and it is also supported by ML, Python actually. Okay, so what are the disadvantages of regex? Brittle is a disadvantage, is included in the disadvantages. Hard to write, can get complex to be correct. Hard to read. See, if you are in maths, even when we are writing a lot of brackets and all the numbers, sometimes our marks get uh, cut by missing those brackets. And similarly, in writing the code for regex, missing one bracket can cause you error, and you will be like, oh my god, I wrote that literally so correct, and why is that happening? It will get hard to like understand and just revisit it when you are like opening that notebook again and seeing, oh my god, this is so like hard to understand and all. So yeah, so then we are revisiting tokenization with regex. This is how we import regex. See, okay, so in this code, let me see what's happening. So yeah, I remember. Okay, so then we are getting let me see. No, okay, actually specifies. Okay, we're not getting anything. Okay, so this code defines a function which is simple tokens talks. So with the parameter of sent, that tokenizes a sentence by adding spaces around punctuation, handling contractions like not, anti, n/t, and comma t, you can see here. So and possessives like s comma, see here, s comma, and replacing multiple spaces with a single space, and then converts the result to lowercase and splits it into a list of tokens. So um, let me correctly, yes, let's skip to that part. That is, yeah, here we are accessing our tokens that are converted from the function above I told you. So these are the tokens we have converted. See, all this happened, comma, more or less, with a punctuation, full stop. Then we have, okay, so once we have our tokens, we need to convert them into integer IDs. We will also need to know our vocabulary and have a way to convert between words and IDs. So importing collections, we have to we have to know what are collections. So a collection is like a group, or assembly of items or objects gathered together, often for a common purpose or as a set. So in this code, let me see what's happening. Okay, so this code tokenizes a list of sentences, creates a vocabulary for them with word counts, inserts special tokens for padding like pad and start of sequence SOS, and generates word to ID. See, it's generating word to ID, of word to ID mappings, and converts that sentences to lists of words IDs, along with returning that related information, obviously. So okay, so what are the uses of regex? So first use is find and search how. So regex is used to locate specific patterns or text within a larger document or dataset, making it valuable for us to pick information retrieval. Then we have find and replace. So it enables actually the identification and substitution of specific patterns or text with like desired alternatives, and streamlining text editing tasks. So then we have it for cleaning. So regex is really handy for data pre-processing, so where it helps to remove, reformat unwanted text or characters like we did before, so enhancing data quality and consistency for our model to understand. So don't forget about Python's str methods. So regex versus str. So regex versus string method is okay. So string methods are easier to understand. In Python it is the syntax is really easy, but still we get some errors in the essay. Okay, so string methods are really easier to understand. String methods express the intent more clearly. As I said, regex can get so hard to read and understand for the logic. So regex handle much broader use cases. Yeah, because we are building logic, so it can handle much broader use cases. So regex can be language independent. Yeah, so it can be language independent. Regex can be faster at scale. Yes, it can be faster because we are writing a lot of logic instead of just using string method. Regex errors. Finally talking about something which is really important. Before even starting we get errors. Yeah, that's simple. So false positive type 1. So matching strings that we should not have matched. False negatives type 2. Not matching strings that we should have matched. So reducing the error rate for a task often involves two kind of antagonistic efforts, like minimizing false positives and minimizing false negatives. So important to have tests for both, so we can just test it in PyCharm. So in a perfect world, you would be able to minimize both, but in reality you often have to trade one for the other. So yeah, finally to an end. So useful tools I have mentioned for regex. You can see regex cheat sheet, regex xr.com, r.com, pyregex.com. So you can actually visit them for more clarification. This is a summary you can get after just completing this lecture. Some regex terms. So regex terms target string. So this term describes the string that we will be searching. So that is the string in which we want to find or our match or search pattern. So search expression, second term. So the pattern we use to find what we want. So most commonly called the regular expression. So literal. So a literal is any character we use in search or matching expression. For example, to find IND in Windows, the IND is a literal string. Each character plays a part in the search. So yeah, you can see a part in the search, IND. So it is literally the string we want to find. So then a meta character I explained before, so no need to explain it again, I think. Then we have escape sequence, which is really simple. We already know about it, but let me tell you, it is also used in Python, like backslash n and all, backslash t. So an escape sequence is a way of indicating that we want to use a meta character as a literal. Sorry. Okay, in a regular expression, an escape sequence involves pressing the meta character backslash in front of the meta character that we want to use as a literal, like backslash in Python adds a new line, and the backslash tab just tap add tab. So yeah, like this. So our regex workflow, let me see why it's stuck here. Okay, over regex workflow, then we have this regex workflow. You can see it. Let me explain. First we will create a pattern in plain English. Obviously we have to plan what we're gonna do. So map to regex language, then map it sequentially, like point to point map it. It will be really, and add comments which will be really helpful. So make sure results are correct, all positives, capture all the patterns, examples of pattern, no negatives, everything captured is from the pattern. Okay, so the fourth one is don't over engineer your regex. Your goal is to get stuff done, not to write the best regex in the world. Filtering before and after are okay. So yeah, the first thing I want to tell you is, like, in coding, it's not like you have to write the best code in the world. You have to write it so it is not like that. You can write in your own way. um, our goal is just to make it work. So see, our goal is just to get stuff done, and filtering before and after are okay, because as we get better we can just filter it and make it more better, because that will be practicing, not getting it more better in the world, making it the best perfect in the world. So here end. So thank you for joining this lesson and listening to it. So bye bye, take care. Till then, keep learning and keep exploring.